Okay, so you can't really ask questions during class if you aren't here. So I'm going to be putting up these kind of guided practice videos where I pick just a few of the questions on the assignment and we go through them. Now sometimes I may go through every single one, but with this particular assignment there's really only one formula and some conversions, so I don't think I'll need to do that. All right, so let's do it. I picked these four. I would be rolling a die for that because there's 12, but for some reason I don't have my 12-sided dice in the classroom. What a slacker. Let's go through them. All right, so remember so far the only formula we've really dealt with is v equals x over t. Your your speed equals distance over time. Okay, so now looking at this thing, we're looking for, in number 3, let's see what it tells us. Bjorn's cart moves at 25 meters per second for 5 seconds. Find the distance traveled. Now we could just do this in our head, but we're not gonna. We're gonna go through the process because that's just a healthy way to do things. All right. So our basic equation we're starting off with is v equals x over t. All right. So we got v equals x over t, but we need to know what x equals. Okay. So to get that t to the other side, it's being divided right now, so we're just gonna multiply it on over. So our distance is just gonna be our speed times our time. Plugging in the numbers it gave us, we've got a speed of 25 meters per second, and we've got a time of 5 seconds. So we're just going to multiply those two together. 25 times 5, hooray, it's still 125. All right, so we got 125, and let's look at our units. So meters per second and seconds, that means those seconds are going to cancel out, and we're going to be left with just meters for our answer. Now, knowing that this thing does have some conversions later on, make sure that you are keeping an eye out for those. All right, so that is number 3. All right, next one, number 6. Okay, so this one's telling us that Wessel's cart travels at 35.1 meters per second. How long will it take for the cart to travel 222 meters? So we're looking for time here. Okay, so if we're starting off with this v equals x over t. Solving for time is the one version of this formula that people often screw up, and it's just because it's in the denominator down there. Okay, so we want to get to time. There's 2 ways we can do it. Let's do it the 2-step way. All right, let's get t to the other side. Right now it's being divided, so we're going to multiply it over. So we get v times t equals x. Okay, now we want to get t all by itself, so how to get rid of that v? It's being multiplied. So we divide by v. Your time is equal to your distance divided by your speed. Oftentimes I see people who have that upside down, and I'm pretty sure it's just because you're solving for something in the denominator. Whenever you're solving for something in the denominator, just take that numerator, stick it over on the other side. Still in the numerator of a fraction. Okay, so we got our working equation. We've got our time equals distance over velocity. All right, it tells us that his cart is traveling at 35.1. Okay, so we're going to plug that in for our velocity, 35.1, and it tells us that it is traveling 222 meters. Okay, so we're going to put 222 in there for our distance, and then now that we've got our numbers, we can just plug and chug. So 222 divided by 35.1, and we end up getting 6.32. 6.32 seconds. And we're done. All right, number 9. All right, so number 9 tells us that Joachim's cart moves at 25 meters per second for 3.5 hours. Find the distance traveled in meters. Okay, so we've got meters per second, but this is in hours, so we can't just plug and chug into our v equals x over t. We need to make sure that everything is in the right units first. This needs to be in seconds. Okay, so we're looking for the distance. We do already have a formula for that we used earlier, so we know that x equals v times t, but we do not know what our time is in seconds, and we do not want to multiply something in meters per second by something in hours, because then our units are mixed and it will cause problems, and we'll just get a garbage, useless answer. Okay, so we can plug the velocity straight in. That's just our 25. Okay, but the 3.5 hours, we do need to figure out how much that is in seconds first. So let's go through the process of converting. All right, so we got 3.5 hours. All right, we want to get it into seconds, so we're going to multiply by a conversion. We want to get rid of hours, so we're going to put it in the denominator so it cancels out. We want to get into seconds, so we're going to put seconds on top. All right, so there are 3,600 seconds for every 1 hour. The hours divide and cancel out, and we're just going to multiply across. So 3.5 times 3,600 divided by 1. 3.5 times 3,600 divided by 1 doesn't change anything. So that means that our time is 1,260. Sorry, not 1,260. 12,600 seconds. There we go. All right, now we're going to plug that in for our time. 12,600 times 25 will give us our answer of a distance of 315,000 meters. Okay, so if you are dealing with units that are not the same between different variables, make sure you convert them all into MKS units first. If you put in that thing in hours, just 3.5 in there, you will end up with a vastly different number. That would be if it was doing 3.5 seconds of travel. Okay, so last one. Number 12. Rowan's cart travels at 35.1 meters per second. How long in seconds will it take the cart to travel 1.7 kilometers? Okay, so first things first, we're starting off with our v equals x over t. We're looking for our time, so solving for time. Just move that numerator over. Our time is our distance over our velocity. Okay, our velocity is in meters per second, so we're all good to just plug and chug that bit in, 35.1, but our travel distance is in kilometers. That's no good. All right, and yes, we could just multiply by 1,000 to get from 1.7 kilometers into meters, but let's do it the long way, just for the sake of example. We've got 1.7 kilometers times, putting our kilometers on the bottom, meters on top. There are 1,000 meters in 1 kilometer. Kilometers cancel out. Hooray! Multiply by 1,000. So that is 1,700 on the top of this thing. And now our time is just going to be divided by 35.1. Okay, so that means that our final time is 48.4 seconds. You will end up with a vastly different number if you don't convert that into meters first. You'll end up with like 0.0484. All right, so always make sure that your units are in MKS units before using our formulas. Okay, there may be some situations where if you've got like a speed in kilometers per hour and you're multiplying by a time in hours to find a distance, it will work because you've got something in per hour times something in hours. They'll cancel out still. But we need to always make sure that we're in MKS units because some formulas will have constants in them that are based on those conversion factors, based on us being in the right units. All right, so we've done 4 of those. If you have any specifically that you need help with beyond those 4, send me a message on Schoology. But it is just using the one formula. You should be mostly okay. See you around.